Math 3, Unit 3, Section 4. Today we are talking about factoring and graphing our polynomial functions. So as we talked about each day, we're kind of building on. Okay, so today we have to first factor before we can actually graph it. Okay, factoring, we know there's lots of different types of factoring. We have greatest common factor where we're taking out the GCF. I'm not going to review how to do this. You guys have been doing this for a while now, I'm hoping. We have differences of two squares. Also should have been written here, and you might not see it very much right now in this unit, but this would be sum and differences of cubes. Okay, that would be another way that we could factor things. Additionally, we have our trinomials factoring, and remember when we are factoring with trinomials, this is where we are getting our multiplication number, which in this case would be negative 30. Our adding number, which in this case would be 7. And then for this one, the numbers that work would be 10 and negative 3. And so we would end up changing our 7x to be 10x and negative 3x. And then remember, we just rewrite everything else. And then we factor by grouping. Yes? Okay. So these first couple problems, we're just going to practice our factoring skills again. When we are factoring, always check for our GCF first. Okay, and then after that, if you have two terms, it's either probably going to be differences of squares or some differences of cubes. And then we also have our three terms, which is dealing with our trinomials. Also be aware that many expressions and equations factor more than once. So you factor everything once, and then you need to check to see if you can factor further. Okay. Starting with this first example. Is there a GCF here? No. The correct answer is no. Okay, so there's no number in front of here, so I can't factor out a number. This has x to the fourth, so 4 x's. This one has 2 x's, and this one doesn't have any x's. So there is no GCF. Since there are 3 terms, we're going to check to see if this will factor using our trinomial factoring. So remember that we always multiply our first term with our last term, and in this case, the multiplication term would be 24. Our adding term is always this middle term here, which happens to be negative 10. Very good. So we start listing all the numbers that multiply to be 24. We have 1 and 24. We have 2 and 12. And I'm going to stop there for a minute because I'm like, okay, 2 and 12, that can make 10, right? And so if I take this one, in order to make a negative 10, what would I need to do?
Negative 12.
Negative 12. Okay, so 2 and negative 12 do add to make negative 10, but when I multiply those together, what do they make?
Negative 24.
And we need a positive 24. So this is not the right set of numbers. And so I'm going to keep going. So I have 3 and 8. That doesn't make 10. We have 4 and 6. That does make 10. Okay, so let's check that. In order to make that a negative 10, what would those need to be?
Both negative.
So when we add those, they do make negative 10. When I multiply them, do they make 24?
Yes.
Good. Okay, so now remember that these two terms, we are basically using our negative 10x squared, and we're splitting them with these two numbers. And so since this is negative 10x squared, when I split that up with these two terms, they are both going to be x squareds because they would need to be able to add together to make that negative 10x squared. So I have a negative 4x squared and a negative 6x squared. Is everybody clear as to why I did that? Okay, and then these numbers don't change. So x to the fourth is still in front, x to the fourth, and 24 is still at the end. Okay? Who remembers what to do next? Not combined like terms. Good, a group, right? We are factoring by grouping. What is my GCF of the first group?
X squared.
Very good. So when I factor out x squared, and if you need to visually see this, divide each of these terms by x squared, and you can see what's happening. So x to the fourth divided by x squared leaves you with x squared. And then here x squareds cancel, and we have minus 4. In our next group, what would be the GCF? Very good, negative 6. Nope. So we're going to divide each of these by negative 6. And anytime you have a negative in front of something that you're factoring, you always want to factor out the negative, okay? So since you have a negative here, we're going to factor out the negative 6. Those eliminate, the negative 6's eliminate, and you're left with x squared. And 24 divided by negative 6 is negative 4. These should match. If they don't, you did something wrong. Do they match? Yes. So now my GCF is x squared minus 4, correct? And so we factor this out, and we have x squared minus 4. And then my other parenthesis is what's left in front of each of those, which is x squared minus 6. We always, once we finish factoring here, we always want to check, can I factor more? So could either of these factor any more? So two terms is when we check for differences of squares or some differences of cubes. Are either one of these numbers, could they be written as squares? Yeah, the 4, right? Because this is x squared, and 4 can be rewritten as 2 squared. Can I rewrite 6 as a square? No. And so x squared minus 4 is going to become x minus 2 and x plus 2. And then we just leave x squared minus 6 the way that it is. And that's as far as it can be factored. Any questions? Okay. So let's go to this next example. Anytime you have a negative in front of your highest exponent, okay, you want to factor out a negative for sure. Okay, because we want our highest exponent term to always be positive. Okay, also, if you notice here, do I have anything else besides a negative that would be a GCF I could factor out? A 3, and then also a, very good. So my GCF is negative 3x, and so I'm going to divide each of these by negative 3x, and I find that when I write it up there, it's easier for me to see what's going to be left over. And so what am I going to be left over here in this parenthesis? X squared minus 9. Is everybody okay with that? Okay, can I factor this further right here? Yes, because 9 can be written as a square. So we have x squared and a 3 squared, correct? And so that means I have negative 3x, and we get x, very good, x plus 3 and x minus 3. And I can't factor that any further. Oops. Okay, sorry. Any questions? All right, remember, if you are finding the y-intercept, you set x equal to 0 and solve for y. When you are finding the x-intercept, you set the y equal to 0 and solve for x. Okay? And remember that when in factored form, you set each of the factors equal to 0 and solve. Okay, moving on. So we were just practicing factoring, and now we have some new instructions here. It tells us to factor, sketch the graph, and label x and y intercepts. So we have 3 different things we need to do: factor, sketch, and label our x and y intercepts. the first thing we're going to do is factor. So if you're looking at this function right here, is there a GCF?
Yeah.
Yes. What would be our GCF?
X.
Very good. So I'm going to take out an x, and I'm left with x squared minus 25. So we just divided an x out of each term. Can this be factored further?
Yes.
Yes, because 25 is a what? 5 squared. Very good. So we factor this and we have x, and then x squared minus 25 is going to factor to be what? Very good. And this is y equals. Okay, so we have now done our first step. We have factored the equation. Now they want us to sketch the graph. In order to sketch the graph, we need a lot of information, okay? When we are sketching our graphs, there's always 4 things we normally write to the side. We write our degree, our leading coefficient, our right end behavior, and our left end behavior. So if you look at this problem, notice here, this is our standard form of the equation. When it's in standard form, the degree is just your highest degree. And so in this case, what is my degree? 3. Now, if you look here, see here it's factored form, we would add each of the degrees of each of the factors. And so this would be 1 plus 1 plus 1, which also makes 3. Okay, so notice the difference between standard form and factored form. Okay, my leading coefficient comes with the variable in front of my highest degreed term. So my leading coefficient on this problem is what? 1, and specifically is that it is positive. Because my leading coefficient is positive, the right end behavior goes to positive infinity. Because the degree is odd, left goes to negative infinity. Okay, now with that information, it's going to help us with graphing, but we need to have each of our x-intercepts. How do we find our x-intercepts? Yeah, we set each of these factors equal to 0. Okay, so this first one, x equals 0. This right here has a multiplicity of 1. Do you guys know why or how I know that has a multiplicity of 1? This exponent here is only a 1. If this had been x squared here that we'd factored out in front, it would have a multiplicity of 2. But because this has an exponent of 1, it has a multiplicity of 1. Anytime the multiplicity is odd, we know it does what? Does it pass through or bounce? Passes through. Okay? X plus 5. When we set that equal to 0, what does x equal? Negative 5. What multiplicity does this one have? 1. Again, this only has one factor. This is only x plus 5. If it had had x plus 5 squared, then it would be a multiplicity of 2. Does that make sense? Okay, and because it's a 1, we know it's going to pass through. X minus 5, when we set that equal to 0, x equals 5, and this is a multiplicity of 1, which means it passes through. Okay, so let's plot all of our x-intercepts on the graph. So we have x equals 0, and I'm going to put a p to remind myself it passes through there. We have x equals negative 5, and I'm going to put a p here because it passes through, and then positive 5. P here because it passes through. Now, do I need to find a y-intercept?
No.
No. How come? We already have one. So anytime we have an intercept at 0, that is also our y-intercept. Anytime there's an x-intercept at 0, it also has the y-intercept, which means we can do less work. We don't have to go in and find the y-intercept, which is nice. Okay? So now that we have all this, can we finish graphing? Okay, so my right end behavior is going to positive infinity. My left end behavior is going to negative infinity. This passes through, turns around, passes through, turns around, and We are done. Let's double check that we have all the information. Did we factor? Yep. Did we sketch the graph? Yes. Did we label our x and y intercepts? Yes. How are they labeled? They're labeled because see how we have these little slash marks here? We know this is at 5 because it's at the 5th slash mark. If you didn't have the slash marks, you would have to mark that this is a 5 or make the slash marks. Does that make sense? Mm-hmm. Okay, so we're done. Okay, next one. This one is a little bit different because it is a composition function. But all it is saying is that you're multiplying f times g together and that it's just of x. So that means that in the equations, as long as these already are x, you just leave them as x's, and we're just multiplying f and g together. That's it. Okay? So if we write this out, y equals, what is my f equation? X times, what is my g equation? Negative 2x squared plus 72. Okay? That is f times g of x. Now, if you wanted to, you could distribute that out, but we're going to end up factoring anyways, right? So there isn't really a purpose in remultiplying that through because we're going to end up taking it out anyways. So I'm just going to look at this piece right here now. Is there a GCF still in this piece?
Yes.
What would it be?
-2.
Good. And again, if you ever have a negative in front of like the highest exponent there, you want to take out the negative. So I'm going to factor out a -2. So we factor out a -2, and we are left with
X squared.
x squared minus 36.
I know it's going to hurt the light here, but I'm going to flip the lights on and you can do exactly what you're doing. I'll just go back in.
Okay, sounds good. Okay, do you notice here how we have the x and then we also have the -2? Anytime you end up having two different factors, two different GCFs, we just multiply them together. So we end up with -2x, x squared minus 36. Okay, can either of these be factored any further? Do you want me to look at it or not?
Just looking out at the kids smiling and talking to them.
Okay, so can these be factored any further?
Yes.
Yes, which one?
36.
Yeah, and 36 is what?
Squared.
6 squared. Good. So we have x squared and 6 squared. And so when we factor this, we end up with, very good, x plus 6 and x minus 6. And then we have y equals. Now,
Perfect. You're done.
thank you. For those watching the video, we just had a yearbook picture taken. Okay. Alto AA.
Yep.
Thank you. Okay, so now we need to list our degree, our leading coefficient. Thank you. Our right-end behavior and our left-end behavior. Okay, what is our degree on here? 3. Okay, so if you go back here and look at this first one, this factor has a degree of 2. This factor has a degree of 1. You add those together, it makes 3. If you go to here, this factor has a degree of 1. This one has a degree of 1. This one has a degree of 1, which also makes 3. Okay? What is my lead coefficient? -2, and specifically is that it is negative. Because my lead coefficient is negative, my right-end behavior is negative infinity, and my left-end behavior is positive infinity because it's an odd degree. Odd degree means opposite directions. Okay, so now we set each of these factors equal to 0. When you set -2x equal to 0, you would end up dividing by -2 to both sides. And what is 0 divided by -2? 0. What multiplicity does this have? 1, which means it's going to pass through. Okay, I'm going to not write the multiplicity. We're just going to talk about it. On this one, x is going to equal what? -6. What multiplicity does it have? 1, which means it will pass through. This is going to be x equals 6, which has a multiplicity of 1, and it will pass through. I believe we have enough information to graph now. So we're going to go and put our points on here and see what happens. So we have a point at x equals 0. and I'm going to put a P to remind me that it passes through. We have a point at x equals negative 6. We're going to put a P to remind us it passes through, and then at 6. Okay, my right end behavior is going to negative infinity. My left end behavior is going to positive infinity. It passes through, turns around, passes through, turns around. Also, we didn't talk about it, but we didn't need to find a y-intercept because I already had the y-intercept at 0. Okay, so we factored, we sketched the graph, and are my x and y intercepts labeled this way? Yes, the correct answer is yes. Yes, they are. Okay. All right, do we have questions before moving on to our next one? Yes?
From step 2 to step 3, how did you get negative
Here?
2? Yeah. How did you
Oh.
get negative 2x but still have x squared?
So, do you see how we already had this? It was like a GCF here, and then we took out another GCF. And so anytime you have two GCFs that you end up taking out, you just multiply them together. So we're just putting them together. All right, yes?
On the x minus 6x, where x equals negative 6 and x equals positive 6, what will it take for it to bounce instead of passing?
If it has a multiplicity of 2, it's going to bounce.
Oh, okay.
So if it had like x plus 6 to the second power, then that would be a multiplicity of 2, which means it would bounce.
Okay.
So even multiplicities bounce, odd multiplicities pass through.
Okay.
Okay? All right, any other questions? Okay, next example. Okay, same instructions on this one, except they also said to answer the questions at the bottom. So we are going to factor, we are going to sketch, we need to label x and y intercepts, and answer the questions. So this time we have 4 different things to do. Okay. So starting here, is there a GCF? No.
No bueno.
Or you can set this aside too. Yeah, so give it to him and tell him. Okay. So no GCF, correct? Okay, so that means we're going to do our multiplication number, which happens to be 4, and our adding number, which is negative 5. Okay, the only numbers that multiply to be 4 are 1 and 4 and 2 and 2. So of those choices, 1 and 4 works, except for what?
Make them both negative.
Very good. They are both going to be negative numbers. So we double check it. You add those, they do make negative 5. When you multiply a negative times a negative, it does make a
Positive.
Okay, so now we are taking this and we are taking these terms and splitting up negative 5x squared into these 2 terms. So when I write this, we still keep x to the 4th, and then I'm going to write negative 1x squared and negative 4x squared, and then plus 4. Because these 2 values are, when you add them together, they make the negative 5x squared. Are we good there? Once you have the 2 terms, what do I do? Grouping. Okay, what is the GCF of the first group? X squared. And when we divide each of these by x squared, what am I left with?
X squared minus 1.
Perfect. Okay, next group, what is my GCF? A negative 4. Good. Anytime there's a negative in front here, you're going to take out a negative, and do you see how they both have 4s? So we're dividing by negative 4. When you do that, you get x squared minus 1. These should match. If they don't match, you did something incorrect. Okay, they do match though, so we are factoring out x squared minus 1. And then my other parenthesis is going to be what? X squared minus 4. Very good. Can either of those be factored any further?
X squared minus 4.
Okay, so this is 2 squared. I agree. This is x squared minus 2 squared. 1 also is a square. Because isn't 1 times 1, 1? Okay, so my factored form ends up being y equals x minus 1 x plus 1, and then x minus 2, and x plus 2. Or it could be in a different order there. Okay, what is my degree for this problem?
4.
Very good. The correct answer is 4. And again, you can see that if you come back here to the standard form of the equation, the highest exponent is 4. If you added this up, this degree would be 1, 1, 1, 1, and 1 plus 1 plus 1 plus 1 is 4. Okay. Looking back at our standard form, it's easiest to see there, my leading coefficient is what? 1, and specifically it is positive. Because my lead coefficient is positive, my right-hand behavior goes to positive infinity, very good. And because it's an even degree, the left-hand behavior goes to positive infinity. Okay. What will I do next? We're going to graph them, okay? Did somebody else say something else? Okay, set these equal to 0 before we can graph, right? Okay, so we set each of these equal to 0. X equals 1. Is that going to be pass or bounce through? Pass, because it has a multiplicity of 1. Okay, this is x equals negative 1. It is going to pass because it has a multiplicity of 1. This one is going to be x equals 2. It's going to pass because it has a multiplicity of 1. This one is x equals negative 2, and it's going to pass because it has a multiplicity of 1. So when we go here, we mark 1 is at a pass, negative 1 is at a pass, 2 is a pass, negative 2 is a pass, and there is something I notice right now. No y-intercept. Okay, I have to find the y-intercept. We need to know the specific y-intercept. Okay? The easiest way to find the y-intercept is when it's written in standard form. Because when it's written in standard form, you end up going y equals, we're plugging in 0 for x, so 0 to the 4th power, minus 5 times 0 squared, plus 4. Well, 0 minus 0 plus 4 gives me what? 4. So my y-intercept is 0, 4. So I need to mark a 4 and put a point there. Or you could have gone, 1, 2, 3, 4. Okay? So now based on my end behaviors, the right side is going to positive infinity, the left side is going to positive infinity. And then we're going to pass through, turn around, pass through. This time it's going to turn around somewhere around the y-intercept, pass through, turn around, and everything works out perfect. Okay, how many x-intercepts are there?
4.
Very good. How many maximums? 1 is correct. How many minimums?
2.
2. Very good. If you're not sure about that, this right here is a maximum, and this point right here, those are minimums. All right, last example. This one says f minus g of x. So, y equals, my f is negative x to the 4th, minus g. This is where you have to be careful. Because it's subtracting g of x, you need to make sure you put that whole function in a parenthesis, because you end up having to distribute the negative through. Do you guys see that? So this is my f function minus my g function. We're going to distribute the negative through here. So I end up with negative x to the 4th minus 7x to the 3rd minus 12x squared. Is there a GCF? What is it? And because this first one is a negative, we're going to factor out a negative x squared. Okay? When you do that, I'm dividing each of these by a negative x squared, which leaves me with positive x squared plus 7x plus 12. Since I have 3 terms, I'm going to check to see if I can factor this using my trinomial factoring. So my multiplication number is 12. My adding number is 7. So, what two numbers work?
4, 3.
Very good. So we have x squared plus 3x plus 4x plus 12. We split these into two groups. First group has a GCF of x, and I'm left with x plus 3. Second group has a GCF of 4, and I'm left with. So that means that ends up factoring to be what? X plus 3 and x plus 4. What you have to really be careful about, though, is what still is in the front. Negative x squared. Okay. So now, when I set those equal to 0, negative x squared, if you set that equal to 0, x just equals 0, but that has a multiplicity of what? 2, which means it's going to bounce. Okay, this next one has x equals negative 3, multiplicity of, which means it passes, and this is x equals negative 4, multiplicity of, which means it passes. Okay, we also need to state our degree, our leading coefficient, our right-hand behavior, our left-hand behavior. Okay, our degree, it's easiest to go back to the original function, which is way up here. Okay, what is my degree? 4. What is my lead coefficient? Negative 1. Good, specifically that it's negative. Because my lead coefficient is negative, my right-hand behavior goes to, and because the degree is even, my left-hand behavior goes to. Very good. Let's go ahead and plot these points on here. So we have a point at 0 and it bounces. Negative 3 and it passes, and negative 4 and it passes. Do I need to find a y-intercept? Nope, because we already have it. Correct? The right side is going to negative infinity. The left side is going to negative infinity. This passes through, turns around, passes through, turns around, and it does end up bouncing. How many x-intercepts? 3. How many maximums?
1.
2 is correct. And how many minimums? 1. So, in case you didn't see it, the two maximums, this is a maximum, and this is a maximum, and this right here is a minimum.